So the ocean affects climate by storing and transporting huge amounts of heat and carbon dioxide. And so if we want to understand how climate's going to evolve in the future, we need to know what's happening in the oceans. About 90% of the extra heat energy that's been stored by the Earth system over the last 50 years is in the ocean. So when we talk about global warming, we're really talking about ocean warming in a real sense. What we're here to do on this voyage is to there are 3 or 4 main parts to the voyage, but basically we're looking at how the Southern Ocean is behaving today, what the temperature, salinity, oxygen, carbon dioxide levels, what organisms are living in the sea and where, and relating those distributions to the ocean currents, and also comparing what we measure today to measurements we've made in previous decades. Work we've done in the past has shown that one of those sinking motions around Antarctica, where water sinks down to great depth, down to 4 or 5 kilometers below the sea surface, that seems to be slowing down with time. The water that sinks is becoming fresher, that is less salty and less dense. We know that in previous parts of the previous periods of the Earth's history, that changes in those sinking motions in the polar regions have been linked to changes in climate. We haven't seen changes in climate result yet from the changes in Southern Ocean currents, but it's moving in the direction that would drive the similar sorts of changes to those we've seen in the past. And the evidence we have so far is that the Southern Ocean is changing. It's warming, and to greater depth and at a faster rate than the global ocean average. And it's also changing its salinity. The salinity changes are important for 2 reasons. One is that part of the salinity changes are being driven by more rainfall and snowfall than happened in the past. That's exactly the sort of signal that we expect to see as a result of global warming. That is, the areas that are dry, where there's more evaporation than precipitation, will get drier and saltier in the ocean. Places where there's more rainfall than evaporation will tend to get wetter or fresher in the ocean. We also see those changes in salinity down deep, right along the seafloor. And that's giving us a hint about how the ocean's interacting with the ice sheet on Antarctica. As the ice spreads off the Antarctic continent into the sea, it starts to float and forms glacier tongues or ice shelves. Where that interacts with the ocean can either melt. If it's warm enough, it can melt the bottom of the ice, or it can actually freeze to the bottom of the ice. The evidence that we found for freshening around the edge of Antarctica is an indication that that melting process is happening more rapidly than it did in the past. And that's a result of the warming of the ocean, we believe. And part of what we're doing on this trip is trying to confirm that picture. In terms of the science, in terms of sorting out what's happening with the climate system and what the impacts of change are going to be, we've made really dramatic progress really in the last 5 or 10 years. And so that's a positive. It means that at least we know what we're doing, and we know what the impacts of that are going to be, so we have a better idea of what to expect if we do or don't act.